So good morning everybody, myself Acharya Vishvendra. Today I'll discuss a lecture on thermal properties of matter. So it's let's start with the heat. So heat was initially supposed to be a form of fluid. Later it was experimentally proved by James Joule that heat is a form of energy. Now heat is a form of energy in transit. Transit means during change. So generally temperature, but state or phase may also change. So there are certain things corresponding to this. The second point that we have to discuss is the the temperature itself. So temperature, the first point is it's a measure of hotness or coldness of a body. Second point is it's measured by thermometer. Third is using different temperature scales. Fourth is all scales are interconnected. Fifth point is there are certain scales and their configuration. For example, centigrade scale has lower point 0 degree, upper 100, number of divisions 100. In Fahrenheit, we have lower point as 32 degree Fahrenheit, upper point as 212 Fahrenheit, number of divisions 180. For Kelvin scale, lower point is 273.15 Kelvin, upper is 373.15 and the divisions are 100. Similarly, for Lumiere scale, lower point is 0 degree Reaumur, upper is 80 degree Reaumur, and we have 80 divisions. Now there is one interesting point that for all the temperature scales, because we assume that temperature is a linear function of the property of matter, generally change in length of the mercury column, or maybe the pressure of gas, maybe the volume of gas, maybe the resistance, but it's a linear function of that. So on the basis of that, we have developed that if you calculate for any scale T minus TL upon Tu minus TL, so it will be directly equal to the property of the gas and is independent of any scale. So that's from where the relation came, and we can say that for any scale T minus TL by Tu minus TL is a constant here. So as discussed earlier, X may be length, volume, pressure, etc. So there are certain relations. 2.7, these are the relations between various scales. These are the relation between change in various scales, as you can see over here. Then we have a graphical analysis, variation of TF with TC, then TQ with TC, then TF with TR. Then we have the concept of thermal expansion, which are linear, areal and volumetric. Then we have the concept of heat. So heat has got two concepts, specific heat and the latent heat. As far as specific heat is concerned, it changes the temperature of the body, and the mathematical relation which is found experimentally is delta Q is ms delta T, where m is the mass, s is the specific heat capacity of the gas, and delta T is increase in temperature. If you calculate the dimensional formula for specific heat capacity, it comes out to be m0 L2T minus 2K minus 1. SI unit is joule per kg per Kelvin. Other unit which we use is generally Kelvin per gram per degree centigrade. For some standard substances like water, specific heat is 1 Kelvin per gram per degree centigrade. For ice, 0.5 calorie per gram per degree centigrade. For steam, it's roughly 0.42 Kelvin per gram per degree centigrade. There is one important question that during melting or boiling, temperature is constant, delta T is equals to 0. So if we calculate mathematically, then specific heat tends to infinity. So this is analysis of this. So you have seen that this is a short video lecture on different topics, and you have seen that we have covered entire content of about 45 minutes in a duration of 3 to 4 minute video lecture. So just use it. It's just to save your precious time and energy. We have just discussed what is needed for cracking the exam. So we'll be coming soon with a set of videos on all the topics of physics soon. So just use it and share your experience with us. If you have any doubt, you can ask in the doubt section. Thank you and have a nice day.